Students, this is question number 4. Let me write the question down. The first term of a GP and the first term of an AP are both equal. That's the first line. Next, the third term of GP is equal to the second term of an AP. And next it says the fifth term of GP is equal to the sixth term of AP. Now all terms are positive and we are asked to find the sum of first 20 terms of AP. Okay, in terms of A. So that is a question, and the question looks very abstract. So let's start with a solution. So let me just start like this. Let the first term of GP be equal to A. Let the common ratio of GP be equal to R. So this means the second term of GP is A times R. Let the common difference of AP be equal to D. Since the first term of GP and the first term of AP are both equal, right? Since given the first term of GP is equal to first term of AP, that means the first term of AP will also be equal to A. This means the second term of AP is equal to A plus D is the second term. Okay. Now we are given the third term of GP is equal to the second term of AP. Now this is the second term for the geometry progression. So now from here I can write, this means the third term of GP will be A times R squared. Okay. From question, what is given? From question, we are given that the third term of GP is equal to second term of AP. So this means A times R squared is equal to, this is second term, A plus D. Okay, so we have one equation there. So I'm going to take it as 2. Also, what is given? Also, the fifth term of GP is equal to sixth term. So also given the fifth term of GP is equal to sixth term of AP. So this will be A raised to the power, A times R raised to the power of 4, and this will be sixth term, A plus 5 into D. So you have another system there. So what I want to do is I want to get rid of this D. So from 2 we get A into R squared minus A is equal to D. put this in 3, we get a times r raised to the power of 4 is equal to a positive 5 times of a times r squared negative a, because that's the value of d. So this is a r raised to the power of 4 is equal to a positive 5 times a r squared negative 5 times a, where these two you get negative 4a, and you have a times r raised to the power of 4. So you divide by a throughout. So what do you get? A gets cancelled. We have got this, and I'm going to rewrite this. This is r raised to the power of 4 negative 5 times r squared positive 4 is equal to 0. I can further rewrite this as r squared raised to the power of 2 negative 5 times r squared positive 4 is equal to 0. So I'm going to let r squared be equal to u. So if I were to take this as a sum 4, therefore 4 can be rewritten as u squared negative 5 times u positive 4 is equal to 0. If you were to use quadratic method of solving, a will be equal to 1, b will be negative 5, and c will be equal to 4. So u is equal to negative of negative 5 plus or minus root of negative 5 whole squared negative 4 times a times c is 4 divided by 2 times of a. This is 5 plus or minus root of 5 squared is 25, positive is going to be 16 divided by 2. This would give me 9, you have plus or minus, and you have 5 there divided by 2. So therefore u is going to be 5 positive 3 divided by 2, which is 8 over 2, which is equal to 4. So u is equal to 4. This is one value. The other value is 5 negative 3 divided by 2. This is 2 over 2, which means 1. So therefore u is equal to 1. But u is equal to r squared. So this means r squared is equal to 4. So r is equal to plus or minus 2. And r squared is equal to 1. So r is equal to plus or minus 1. So root of 1 plus or minus 1. Now the point here is we cannot actually take r is equal to 1. The reason being, it is given that the roots, or I would say the values, are not equal. Okay, so let me show you the question. The question, I'm writing the question, given that all are positive, all terms are positive and they are not equal. So this means r is equal to negative 2 and r is equal to negative 1 and r is equal to 1 are all dropped. Right, because negative cannot be there, and equal to, they are also not equal. So r is equal to 1 is also not possible. So therefore the value of r is equal to 2. Okay, so this in turn means we got the value for d. D is a times r squared negative a, which is nothing but 2 squared negative a, which is 4a negative a, which is equal to 3a. Now we need to get the AP for 20 terms. So this is the formula. S is equal to n over 2 and 2a plus n minus 1 into d. Right. So you substitute for n is equal to 20. So what happens here? This is 20 over 2 times a positive 20 minus 1 times d is 3a. So this would give you 10, and this will give you 2a plus 19 times 3a. So this, I'm going to complete it here. Now 19 into 3, what is that? 9 3s are 27 to 57. So you have 2a plus 57a. This is 10 times 59a, which is 590a. What is this? This is S. Okay, that's exactly what they want. So that's a solution for this question. Let's move on.